In this first section of our algebraic fractions unit, we're going to look at simplifying. And that's what we're going to do actually in our first couple sections, and what you're going to find is that every section actually requires us to simplify fractions at some point. So this is a skill we will reuse all the way through. First section, as compared to the second section, we are going to be using fractions of monomials as opposed to bi or trinomials in section 2. And the difference is there is one term up on top, one term on the bottom in these fractions. And if you look ahead, you're going to see that we see two terms or three terms all in the same fraction in the next section. And so we're going to focus on how do we reduce in this situation, and then how does that change in the next one. The other thing that we're going to run into is this idea of excluded values, and that's something we haven't paid any real attention to yet. Excluded values means that even though we've reduced this fraction, are there certain numbers where if we were to plug them into the simplified version, it wouldn't equal the original one. So it equals the original one most of the time, except in these really weird cases. And we're going to keep track of that by looking at what things cause our denominator to equal 0. So let's go ahead and jump into this first example. We have 8n cubed over 20n to the fourth. And the way I'm going to approach this is to say, what goes into both 8 and 20? What can they both be divided by? And I'm going to actually break it out. So I see that 8 and 20 are both divisible by 4. If you didn't know that, but you knew they were both even numbers, you could say, well, they're at least divisible by 2, and then you might end up just having to do that again. That's okay. So I'm going to break this to 4 times 2, since I know that it's divisible by 4. And 20 is 4 times 5. I'm going to get rid of the 20. Whenever I factor something out or break it into factors, I always like to scribble out the original thing, because otherwise I'm not going to remember what has been replaced and what has just been changed in some way or added. And so it always helps me when doing these problems to cross things out. As far as the ends go, I see that the top and bottom both have at least 3 ends. And so I'm going to take this n to the fourth and rewrite it as n to the third times n to the 1. 3 n's and 1 more make 4 n's. I'm going to replace that. And I was very intentional about how I wrote this out in a way that says, hey look, there's a 4 on bottom, 4 on top, 4 in the numerator and denominator. Those eliminate each other down to 1. They reduce to 1. Same with my n cubes. I have an n cubed and an n cubed. Eliminate to 1, leaving me with just a 2 on the numerator and then a 5 and an n to the 1 on the denominator. So I could write this as 2 over 5 n to the 1, or I could just write it as 2 over 5 n. The 1 isn't necessary. So this would be my reduced fraction. That other part that says what are the excluded values says go back to the original fraction and say what would happen if you took that denominator right there and set it equal to 0. What would you get? So for the excluded value, we take that 20n to the fourth and set it equal to 0. If our goal is to get n alone, we would divide by whatever number is being multiplied by n. So if we have 20 times n to the fourth, we divide by 20. Now, since we have 0 over here, 0 divided by 20 is 0, so we get n to the fourth equals 0. And it turns out that if we want to undo a power, we take that root. So if we want to undo a square, we take the square root. If we want to undo the fourth power, we take a fourth root. But what's cool about 0 is that any root of 0, any whole number root of 0 is going to be 0. So n is equal to 0. That's our excluded value. When we're dealing with these monomial over monomial problems, if there is any variable in the denominator, it's always going to be 0, because we are always just doing multiplication, and 0 times anything equals 0. So expect to see a lot of answers of 0 in these problems. When we get into section 2, we're going to start seeing other numbers pop up since there's addition or subtraction being involved. So our two pieces to our answer in this problem is the 2 over 5n, the reduced fraction, and the n equals 0, the excluded value. And so if we were to have simplified this in a way that involved not having an n in the denominator, we might not have known about that n equals 0 being a problem. Let's do one more example. Let's actually slide over here to number 10. When we want to find the simplified version, it's always easiest to start with the whole numbers. I see a 15 and a 12, and I know they're both divisible by 3. So I'm going to rewrite the top as 3 times 5, and 12 as 3 times 4. For my b's, I see that they both have at least 2 b's being multiplied by each other, so I'm going to write the top as b to the second times 1 more b, and scribble out that b cubed. Then we're going to eliminate things that are the same top to bottom, so I have a 3 and a 3. I'm going to divide out to 1. I have a b squared and a b squared divide out to 1, leaving me with the simplified version of 5b to the 1, or just 5b, over 4. And that does not reduce any further. So that is my simplified answer, my simplified fraction. And then for our excluded values, I go back and look at the denominator. 12b squared equals 0. And I always set it to 0, and the reason is because the reason it's excluded in the first place is that when you divide a fraction, when you divide something by 0, it doesn't work. Try dividing by 0 in your calculator, you'll get an error because it's impossible to divide something into 0 pieces. And so that's why we set the entire denominator, this whole thing down here, equal to 0, because if that were to ever give us an answer of 0, the math problem wouldn't work. It would break the laws of math. So getting back to this, 12b squared equals 0. We get b alone by dividing out the 12. We undo squares with square roots. Whatever we do to one side, we do to the other, leaving us with b is equal to, technically there should be a plus or minus, same with the last problem, but it's 0, so plus or minus 0 is 0. We'll deal with some of those technicalities later. b equals 0 is our excluded value. And if you want to abbreviate that as EV or something like that, as long as it's very clear what you're talking about, that will be totally fine. Only thing to watch out for in these problems here is things like this negative here. I always put negatives on top, so I would make that become a -4 and scribble that negative out there, because otherwise people just tend to lose it. So hopefully that helps you with the simplifying.